glowing server rack emitting intense heat illustrates the current reality of AI audio synthesis. Running modern voice cloning models almost always requires renting expensive cloud servers or managing massive amounts of VRAM locally. That heavy computational requirement creates a hard barrier to entry. High-fidelity voice generation routinely locks out everyday creators simply because of the sheer cost of the hardware needed to process it. Valtec TTS strips all of that away. It is an open-source alternative built specifically to operate offline, removing those heavy hardware dependencies entirely. This side-by-side scale shows the core technical hook. Valtec uses exactly 74.8 million parameters to perform zero-shot voice cloning natively on a standard CPU, processing audio 3 to 4 times faster than real-time. Dropping the parameter count to under 75 million resets the baseline expectation for local performance. It proves that high-quality AI audio no longer demands a massive graphics card. It seems mathematically unlikely that such a lightweight model can achieve precise vocal cloning without GPU acceleration, so we have to look closely at how it divides the workload. This breakdown shows a modular design. The workhorse is a 56.45 million parameter synthesizer responsible for voice generation. A specialized 8 million parameter speaker encoder extracts the vocal identity. Separating these specific tasks allows a standard CPU to run the entire inference process without bottlenecks. That exact architectural division is what enables zero-shot cloning. The model requires absolutely no training time or fine-tuning to map a target voice. Just provide a single audio clip. Between 3 and 10 seconds long. Anything under 3 seconds provides too little data, and anything over 10 seconds is ignored by the encoder. This intelligent modularity allows standard consumer hardware to completely match the zero-shot capabilities of much heavier brute force server algorithms. Beyond identity extraction, this small architecture also features a dedicated 7.8 million parameter style encoder. This waveform mapping illustrates Prosody Transfer. The model pulls the exact intonation, rhythm, and emotional cadence from your reference clip and applies it to the newly generated text. This process replicates the speaker's biological sound alongside their specific rhythm and intonation. This modular approach also enables one of the repository's hidden gems, speaker interpolation. This visualization shows exactly how that functions. You can input 2 completely different speakers, and the model mathematically blends their data in the center to create a third distinct vocal profile. You can dial in the exact ratio of the mix to synthesize entirely unique voices that do not exist in the real world, straight from your local machine. Giving creators direct control over emotion mapping and voice blending turns this tool into a comprehensive, offline vocal directing suite. Prioritizing local efficiency also provides critical support for regional creators who often face steep language barriers when using mainstream platforms. Valtec includes a native Vietnamese phonemizer built specifically from the ground up to parse the complex tonal differences between northern and southern dialects perfectly. The developers also actively removed the usual technical friction: no installing Python libraries, no messing with command line prompts, or writing any code. This desktop application mockup shows the final result. The entire AI is packaged into a nearly 400 megabyte offline Windows executable file. You simply click, type your text, select a voice, and hit generate. There is one specific limitation you need to know before downloading it. The repository operates under a strict CC BY NC 4.0 license. That means it is free to use for personal content, offline research, and local testing. But commercial use is restricted unless you secure written permission from the developers. Even with that licensing restriction, highly optimized tools like Valtec TTS prove that you do not have to rely on gate-kept, cloud-based processors. You can run high-fidelity audio generation on the hardware sitting on your desk right now. If this breakdown saved you time, make sure to subscribe and click the bell for more weekly reviews of local AI tools. You can find the GitHub and download links for Valtec TTS in the description below.